Hi there. This is a video about solving linear equations. Today we're going to look at one-step equations where it requires one step to solve the equation. Now before we do anything, we have to think of the word opposite or inverse. And so when we think of opposite or inverse operations, this is the mindset that we want to have when we're solving an equation. So I want to first look at one of our operations, and that first operation is the word addition, okay? What's the opposite or inverse of addition? And that would be subtraction. Think of another operation like multiplication. Okay, the opposite or inverse operation of multiplication is division. Okay, so when I do this, I say what's the opposite of addition? That's subtraction. What's the opposite of multiplication? That's division. And that goes the other way as well. The opposite of subtraction is addition. The opposite of division is multiplication. So we're going to use this to help us solve an equation. So let's say that we start off with some equation where x plus 4 is equal to 7. And what you're really saying here is you have some number, you add 4 to that, and you get 7. So then we're trying to figure out what's x equal to, okay? And you can intuitively think about this, and we know that x is going to be equal to 3, okay? So, but what we want to do is we want to use inverse operations to isolate x and solve for x, okay? So because I'm taking some number x plus 4, what I want to do is I want to take this number and I want to move it to the other side of the equation. And in order to do that, I have to look at what I'm doing with the 4. Since I'm adding 4, I want to do the opposite of adding 4, which is subtract 4. So let's do that to both sides. Okay, so if I do it to one side, I have to do it to the other side. And as a result, okay, I do the math, and I got 4 minus 4, which is going to cancel out to 0, okay? And then I have 7 minus 4. So 7 minus 4 gives me 3. I'm going to drop down my x, and I get that x is equal to 3. Now we can always check, okay, and substitute x back in, 3 back into our equation, and evaluate and see if we get a true statement. So we would do 3 plus 4 is equal to 7. 3 plus 4 is in fact 7. 7 is equal to 7. That's true. So this is my solution. Okay, let's look at another example. So in this example, what I'm doing is I have some number t minus 5 gives us negative 2. So this one's a little bit trickier. This one isn't as easily done in our heads. So this requires us to do a little bit of algebra. Now remember, you have t here. You want to move all the other numbers to the other side of the equal sign. So what I'm looking at is I'm looking at this negative 5. Okay, I have to move this over. So what I want to look at is the fact that I'm subtracting a 5. So the opposite of subtracting 5 would be to add 5. And I'm going to do that to both sides, okay? And so then negative 5 plus 5 is going to add to 0. And then I get that t is equal to negative 2 plus 5. And you can think of that as 5 minus 2, which is going to give us 3. All right, so t is equal to 3. All right, now, again, we can check this, all right, just to see if we're right. You can always check to see if you solved an equation correctly. So I've got 3 minus 5. Is that equal to negative 2? All I'm doing is I'm taking 3 and plugging it back in for t, okay? And so now I can do 3 minus 5, which is going to give me negative 2 equals negative 2. That's true. So we're good, okay? Let's look at another example. Okay, and in this example, I've got negative 3 a equals 15. Now, because I have negative 3 right next to a, the operation that I'm doing is multiplication. And so, we're at a point where we don't use the x to represent multiplication anymore because we usually look at x as a variable, okay? So here I've got negative 3 times a, so I use the dot to show multiplication, or I could use parentheses, doesn't matter. So I have negative 3 times some number a is going to give me positive 15. So what's a going to be? Now this one we can probably do in our head, And we probably think that 3 times what number gives us 15? Well, that's 5. But since 3 is a negative, and a negative times a negative gives us a positive, then A would have to be -5, okay? So let's do some inverse operations to get to that point, all right? So if I'm multiplying by a -3, then what I'd want to do then is divide both sides by -3, okay? Now, -3 divided by -3 is going to divide out to 1, okay? And we can just cross that out. And you're just simply left with A on the left side. Now, to do this math over here, I got to do 15 divided by -3, which gives me -5, okay? Which is what we got initially, all right? And so, this is my answer. And we can always check, all right? And I can take -3 times, and I'm going to put this in parentheses, -5 is equal to 15, okay? -3 times -5 is going to give me +15, which is equal to 15, and that's true, okay? So that's what I've got there. Let's look at a final example. Okay, so in this last example, you have some number f. We divide by 4, and we get 6, okay? So we want to think about what f is, and you can think of f, what divided by 4 is going to give you 6, and that's going to be 24, okay? So that's what I think the answer is. Let's do some inverse operations to get there. So if I have some number f divided by 4 and we get 6, what I want to do is I want to isolate my variable and I want to move my 4 to the other side of my equation. So if I'm dividing by 4, the opposite of dividing by 4 is to then multiply by 4. And I'm going to multiply by 4, okay? And so what I have here now is I have 4 divided by 4, which divides out to 1, okay? So I can cross those out, and I'm just left with f on my left side, and I have 6 times 4, which is 24, okay? So that's my answer. Now we can always check, all right? And I can do 24 divided by 4. Does that give me 6? And 24 divided by 4 does give me 6. 6 is equal to 6. That's a true statement, okay? So these are just one-step equations, all right? So we have to understand one-step equations before we can start doing two-step equations, multi-step equations, and all that, okay? So hopefully this makes sense. Have a good day.